Good morning, friends. Welcome back. Today we will be discussing one more important concept in operating systems, that is nothing but CPU scheduling. As we have discussed in our previous video, process synchronization. Process synchronization is closely related with the concept of CPU scheduling. Now we will be discussing some of the important terms in the concept of CPU scheduling, and slowly we will go into the concept of CPU scheduling. Before going into the concept of CPU scheduling, as a student of operating systems, you need to know some of the concepts like what is process ID, what is arrival time of a process, what is burst time of a process, what is waiting time, response time, turnaround time, and efficiency of a process. When do you call a particular process to be efficient and everything. Now, moving on to the concept of CPU scheduling. What is CPU scheduling? The CPU scheduling is the process by which a process is executed by using the resources of the CPU, which means that, as I have told you in my previous video of process state transition diagram, for a particular process from the starting state to go to the termination state, it should get the time to engage with the CPU. So the time that it gets to engage with the CPU, what does this process do when it gets the CPU to do work with it? So mainly with the help of the resources that are available with the CPU, the process satisfies its work and goes into the termination state. Now the process also can wait due to the absence or unavailability of resources. As I have told you, when there are n number of processes coming and waiting in the ready queue, there may be unavailability of resources because in the critical section, according to the terminology and according to the rules of process synchronization, only one process can exist. So when one process is already busy in the critical section or already busy with the CPU, other process have to wait due to the absence or unavailability of resources. But these processes make the complete use of the central processing unit, that is nothing but the CPU. The operating system must choose one of the process in the list of ready to launch process whenever the CPU gets idle. The main, if whenever suppose you call a particular operating system as an efficient operating system only when the CPU is in continuous process. It is no way idle. A temporary CPU scheduler does this selection. As I have told you, the process from the ready state will be picked up and sent into the run state with the help of a short-term scheduler. The scheduler chooses one of the ready to start memory process and to get into the CPU. Now coming on to the CPU scheduling algorithms, my dear friends, there are four types of important CPU scheduling algorithms in operating systems. The first one is first come first serve. As the name suggests, the process which comes first will be served first according to the arrival time. The second one is the shortest job first, SJF. The third one is the round robin algorithm, and the fourth one is the priority scheduling. Now moving on to the concept of these algorithms, you people need to basically understand some of the meaning of some of the important terms that we will be using in the procedure for solving the problems. The first one is process ID. The process ID is the first thing to be written while solving the problem. Whatever problem you take, whatever algorithm you take to solve the particular problem, whether it may be a first come first serve problem, whether it may be a shortest job first algorithm, whether it may be a round robin or priority scheduling, whatever may be the problem, to solve a particular problem, you need to know what is process ID. The process ID is the first thing that is to be written while solving the problem. The process ID acts like the name of the process. Like as you all know, when you are solving a problem, if your teacher or if someone tells that 10 process had arrived, immediately if they ask you to implement that problem using priority scheduling, you can't draw you can't draw the Gantt chart without knowing the process ID, because how many process are there, how many process have completed its execution with the CPU. To have a clear understanding and idea about all of this, you need to have a number to the process. So generally, like the name of a student and like a name that is given to the human being, process ID is the name that is given to a particular process. Usually we start naming the process from 0. We can also start numbering from 1. It is our interest. So my dear friends, generally if there are 10 process, the process will be given named accordingly, like P0, P1, P2, P3, P4, as a result of which you can easily solve the particular problem by implementing a suitable algorithm. Now moving on to the next heading, what is arrival time? The time which is required for the process to enter the ready queue, or the time when the process is ready to be executed by the CPU. This arrival time can be represented as AT in short form. the arrival time is always positive or also zero. Arrival time is nothing but, my dear friends, what time, at what particular time the process had arrived. Suppose, even though the process, suppose the process may arrive before 1 hour, but from 1 hour that process is being waiting in the ready queue, because as I have told you, due to the unavailability of resources, the process is waiting in the ready queue. So that time will not be considered. The time at which the particular process will come and join with the CPU, which means that by all certain means, by the means of resources, by the means of input output request, by the means of solving or attending those input output requests, by all the means, whether the particular process is ready or not to be executed by the CPU. This time when the process is ready, so that yes, I am ready, now I can easily go and complete my work with the central processing unit or operating system. That time is called as arrival time in short. The arrival time is always positive or always zero. As I have my, it is a common sense, my dear friends. Arrival time cannot be negative. If arrival time is negative, which means that a process does not exist at all. Now coming to the heading, what is burst time? Burst time is nothing but the time slot which the process requires to complete the process is known as burst time. The burst time can be represented as BT. In short form, the burst time of a process is always greater than zero. Burst time is nothing but the time that is required by the process for the time that is required for the process to complete its execution for the CPU. My dear friends, as I have told you in my previous lecture videos, the process that will go and attain or work with the CPU will vary from each to each process. Suppose process, there are two process P0 and P1. P0 may go and engage with the CPU for a longer amount of time, whereas the process P1 can, with by the availability of all the resources, can complete its execution only within 10 to within a few seconds or few minutes. So how much time the particular process is being engaged with the CPU, this time is known as the burst time. Now coming, what is waiting time? The time the process has been waiting to complete its process since the assignment of process for completion is known as waiting time. The waiting time can be represented as WT in short form. The waiting time can be calculated with the help of turnaround time and burst time. This is a very very important concept, my dear friends. They will be asking you in the questions which we will be seeing in the upcoming videos how to calculate the waiting time. Waiting time is mainly calculated with the help of turnaround time and burst time. Waiting time is nothing but how much time, since how much time the particular process is being waiting in the queue. Suppose the particular process had arrived at the interval of 1 and now the interval is 4, which means that the particular process P0 is waiting in the CPU since 3 units. So this is called as waiting time. Okay, my dear friends. Now the formula, I request all of the students who are watching this lecture to note down this particular formula. Waiting time can be calculated by the difference between turnaround time along with the burst time. My dear friends, I'll give you a 20-second time gap. Please, all of you, note down this formula, which is very, very important and which will help us a lot for solving the problems in the upcoming lectures. Okay, friends, upon continuing, the next topic is response time. The response time of a process is mainly referred to the time it takes for a system or a computer to respond to the users or input. In the context of computing and operating systems, response time is often associated with the time it takes for a process to start executing after a user initializes an action or a task. It can be considered as the time from the initiation of a command to the first visible response or output from the system. My dear student friends, response time is nothing but, suppose at a particular point of time the CPU is idle. So when the operating system notices that the CPU is idle, immediately it will take a process from the scheduler will take a process from the queue and it will give it to the CPU. Now immediately when the scheduler goes to attend a process, all the process may be inactive. Some of the process may be sleeping, some of the process may be busy in another work, some of them may be lazy to go. So these all kinds of actions will be shown by the process. These all kinds of actions are will be shown by the process. So to avoid all these kinds of actions, there is a concept called convoy effect, which we will be discussing in the upcoming few videos. Now, in the response time, what is response time is when I request for a particular process to go and work with the CPU, after how much time it has become active, after how much time that particular process is responding to the scheduler. So this is called as response. What is turnaround time? Process has been ready to execute in the ready queue is known as turnaround time. So how much time now? Response time is the time that is mainly dedicated only to the process, but turnaround time is the time that it is dedicated to the CPU. அது என்னல வந்து what is turnaround time is now the process is ready. Sir, process is ready to execute, but CPU is not ready. Process had come and it is waiting, but CPU is not ready to work with the process. How much time, after how much time the CPU will accept its request, the process request, and allocate the resources? It's called as turnaround time. Turnaround time is generally represented as T8. Turnaround time is the difference of completion time and arrival time. So this is also important formula, my dear friends. Turnaround time is equal to completion time minus arrival time. This is the formula to calculate the turnaround time. You please I request you to note down. This will be very helpful for us in the upcoming lectures to solve the problems. Now we will be moving on to the concept of Gantt chart. Now, my dear friends, I am telling from these many videos, you may tell, sir, what, sir? You are simply telling process are coming, process are going, process are executing with the CPU, process are getting the resources allocated. Another, sir, how to visualize it? We are not able to see any process. Asal, are you telling the truth? Really, our process coming? Really, is this executing happening, or just we assuming and solving the problems? No, my dear friends, you are completely mistaken. This particular visualization of process is called as Gantt chart. Gantt chart will mainly represent at what time the particular process had entered into the CPU, how many units of time it had spent with the CPU, at what time that particular process had left the CPU. This all is recorded in the form of a chart, in the structure of a chart like queue-like structure, which is called as Gantt chart. I once again tell you, my dear friends, Gantt chart is very, 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 very important and helpful and very, very useful for calculation of all the above mentioned concepts like turnaround time, burst time, waiting time, and also solving the problems in the algorithms. Now, coming to the first algorithm, my dear friends, first come, first serve algorithm. FCFS, CPU scheduling algorithm, very, very, very important algorithm. This is the first type of CPU scheduling algorithm. Here in this CPU scheduling algorithm, we are going to learn how a CPU is going to allot the resources to the certain process. My dear friends, I tell you to avoid conflict as the name suggests, first come first serve basis. The process which comes first will be given to the CPU first basing on the arrival time. I once again repeat, the resources or the central processing unit will be given to the process basing on the arrival time of the process. We can also say that the first come first serve CPU scheduling algorithm follows first in first out ready queue order. FCFS is in short form called as first come first serve. What are the characteristics of this algorithm? First come first serve can follow or can be executed in preemptive approach and non-preemptive approach. You may be having a doubt what is preemptive or non-preemptive approach. We will be going through these concepts in the upcoming videos. The process which enters the ready queue is executed first. So we say that FCFS follows first in first out approach. I once again repeat, understand clearly, my dear friends. The process which comes first into the ready queue with no other idea, with no other thought, immediately whatever may be the priority of that process, whatever may be the state of that process, whatever may be the particular condition of the process, nothing will be bothered. If it is the first process to arrive into the ready queue, immediately this first come first serve algorithm will take the process and will go and give it to the CPU, so that that particular process will can complete its execution with the help of CPU. Okay, friends. First come first serve is only executed when the arrival time is greater than or equal to the time which it is at present. Now, what are the advantages? It is very easy to perform. It follows FIFO queue approach, first in first out queue approach. And what are the disadvantages? Is it is not very efficient. It mainly suffers from convoy effect. My dear friends, as I have told you, what is convoy effect? FC first come first serve algorithm may suffer from the convoy effect if the burst time of the first job is highest among all. As in the real life, if a convoy is passing through the road, then all other persons may get blocked until it passes completely. This can be simulated in the operating system also. If the CPU gets the process of higher burst time at the front end of the ready queue, then the process of the lower burst time may get blocked, which means that they may never get the CPU if the job in the execution has a very high burst time. This is also called as convoy effect or starvation. My dear friends, I tell you what is convoy effect. Suppose there is a ready queue, my dear friends. In the ready queue, there are four process P0, P1, P2, P3, and P4. Okay. Now, the process P0 is having a very high burst time of 24. Suppose let us think the burst time of process P0 is 24. The burst time of process P1 is 10. The burst time of process P2 is 1 unit. Now, according to first come first serve algorithm, the particular algorithm will not see the burst time. It will simply send the process which had arrived first. Let us think that process P0 has arrived first. So what will happen? Immediately the queue will send the process P0 and assign it to the CPU. So, as a result of which 24 units until 24 units of the burst time of that particular process complete, that process will not leave the CPU. As a result of which, my dear friends, what will happen? You think the remaining process that had already come and are waiting in the queue will suffer from starvation. So, then also due to this convoy effect, there may be some process that will never ever get a chance to work with the CPU. They will suffer from starvation. They have to come, they have to wait. By that, okay, let us think that the process somehow process P0 has completed its 24 units of execution and has left. By the time these 24 units are getting completed, one more process with 10 units will come. So as it is recently arrived, that process will be given to the CPU. So now if this process if this scenario continues, once, my dear friends, you think what is the condition of the process P2 which is having a burst time of 2 units? It will literally start sitting and crying. Please give me the CPU. I am having a very low burst time. That is only 2 units. I will complete my execution in a very short time and I will leave. But it won't get the CPU. So this is a main problem that we will be facing in first come first serve CPU scheduling algorithm, my dear friends. Now we can usually visualize using a diagram. This is the longer job and these are the shorter jobs. This is the front truck is the CPU. Shortest job first algorithm. This type of CPU scheduling algorithm will mainly give the process to the CPU basing on the burst time. Now in this particular algorithm, the process that I have told you, which is having very less burst time of 2 units, will be the given first priority to work with the CPU. As a result of which there won't be any starvation effect in this particular shortest job first. What are the characteristics? Means it has the least average waiting time. All the heavy processes are executed at the last. So because of this reason, all the very small and small processes are executed and they prevent starvation. Okay, it is used as a measure of time to do the each activity. Okay, my dear friends, what are the advantages? Least average waiting time, and it also be called as long-term CPU scheduling algorithm. Some of the disadvantages are starvation is one of the trade shortest job first. One becomes difficult to forecast how long the CPU request will take. Okay, now moving on to the next algorithm, that is round robin algorithm. Round robin algorithm is that this particular round robin algorithm will mainly work with the concept of time slicing. Each process will be given a time slice, means like a token system. Process P0 will be given with a token, process P1 will be given with a token, process P2 will be given with a token. Each token will only be of 2 units. So after the 2 units of token is over, immediately even though it is a priority process, nothing it will care. The CPU will kick out the process, and immediately another process will come. It will execute until its slicing is over, time slice is over. Immediately that will be kicked out like that. See, that's that all the process that have arrived will get a chance. This is very 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 important algorithm. Most of the university examination questions will be problematic questions will be based on round robin algorithm. If you are having laboratory component for operating systems which is implemented in Linux programming, definitely for your, I am telling you my dear friends, for your university end semester exam, lab exam, definitely this round robin algorithm will be coming. Direct question of round robin will be coming. Now coming to the last thing, that is priority scheduling. Priority scheduling is every process will be assigned with a number that is called as priority number. Highest number is considered as highest priority value, lowest number is considered as lowest priority value. Don't worry my dear friends, this priority will be mentioned in the question itself. Basing on the priority, if the particular process is having highest number, it is having highest priority, so immediately it will be given to the CPU. Lowest number means it is having very low priority, so basing on that value of priority, it will be given to the CPU. Organizes tasks according to the importance. When a task is with lower priority, it is being performed, while a task with higher priority arrives. The task with lower priority is replaced by the task with higher priority, and the later it is stopped until the execution is finished. What are the disadvantages? Again, you can see is the mainly the starvation problem is one of the preemptive priority CPU scheduling algorithm which prevents flaws. Because of this issue, a process, suppose process P0 is having a priority of 1, so that process is being given to the CPU and it is working. So suddenly a process P1 comes that is having priority of 5. As you know, higher the number, higher the priority. So this process will be literally kicked out in between, and that process will be given chance to work with the CPU. Again, higher priority process will come. Like that, it process will become process will start coming continuously. What will happen? This particular process which is kicked out in between will suffer from starvation. Now we will discuss what are different modes in CPU scheduling algorithms: preemptive approach and non-preemptive approach. In preemptive approach, the process one starts execution. This is very important, friends. Preemptive approach ante, suppose if a particular process had started its execution path, what will happen is, apart from nothing, like whether it is priority, whether it is time slicing, whether it is having higher importance, whether it is having low burst time, high burst time, first come first serve, everything will be kicked away, nothing will be checked. If preemptive approach means once a particular process had been given to the CPU, until and unless that particular process had completed its execution, no other process can come, and CPU allocation will not change until the process is complete. Once it starts its execution, the CPU is allotted to the same process until the completion of the process. There will be no shift of the process. This is called preemptive. In non-preemptive, once it starts its execution, not allotted to the same process. Shift in process, there is a shift in process. Complete CPU is allocated to the process when only certain required conditions are achieved, and there will be a change of CPU allocation. Non-preemptive approach means, suppose as I have told you, all these cases will come into consideration. Suppose a process is being given to the CPU and it is working. Suddenly another process with higher priority comes. If it is a non-preemptive mode means, the process that is already being working with the CPU will be kicked out, and the process that has arrived newly will be given the chance to work with the CPU. Similarly, if the time slice of a process over, as I have told you, the concept of time slicing in round robin, that process will be kicked away, and the process that had come newly will be given chance. Okay friends, this is these are some of the important CPU scheduling algorithms that you will be learning in operating systems. Now, thank you my dear friends. In the next class we will be mainly seeing 2 to 3 problems on each of the CPU scheduling algorithm, basing on which you will be getting a clear clarity how to calculate the turnaround time, how to calculate the waiting time, how to calculate the burst time, along with which you will learn how to represent this process in the Gantt chart. Thank you. Thank you, my dear friends.